Yes. So yesterday we were describing the block diagram of two area load frequency control, which was uncontrolled. Means here you see it is the block diagram of generator. This is one control area. Area one. This was the area two. Power flowing from area one to two was depending upon the two frequencies F1 and F2, and that power is called as a tie line power, which comes to be here. And if any demand, if demand changes here, it affects not only this area, it affects this area also, because this demand will affect the frequency, and this frequency will affect the tie line power, and the tie line power of this will affect here this input, and finally this frequency also. So everything is affected, either demand of this side or this side, the overall system is being affected. And this is the generator of area 1, this is the turbine of area 1, this is the speed governor equivalent of area 1. And if the demand changes, what will be the effect on frequency in primary automatic load frequency control? Means when the speed is changed with the help of speed governor, then by the time when the input becomes equal to output, by the time sub frequency goes down, and finally the response came out to be, response of this was, yesterday when we were describing, we told the response of this was like this. The frequency of area 1 is this, frequency of area 2 is this, or frequency of area 1. If the demand changes in the frequency and the demand changes in the area 1, then frequency of area 1 affected more, then frequency of area 2 is also affected. And then this was the steady state error. Means steady state means after a long time, after a time constant, also the frequency change in steady state change in frequency remains, or we can see the steady state change in the frequency. But we actually don't want this change. We want, as soon as this is over, when the disturbance is over, demand change is over, finally the frequency should also come to the 50 hertz here. Means no change should be there from the normal frequency. So this should be 50 hertz. That was our intention. With this intention, what we do here, with this intention, we apply an integrator here. We apply an integrator here. That the signal, this signal, frequency signal, it is not only frequency, or you can say this actually this was the speed signal here, which was being fed up here, and ultimately the frequency signal is nothing but the frequency signal. Speed signal is nothing but frequency, and that frequency signal is integrated here. If you integrator is applied here, this frequency signal is given as a feedback to the integrator, and that integrate by the time means time it takes to come to the steady state value. By the time the signal is integrated, then it is applied here. So this, when this is applied here, it also changes the input power. Means it changes the YE opening, and finally the input is equal to output, and by that time the more input is allowed, and the frequency becomes the steady state normal frequency. With that intention, this integrator is applied here. So the new figure, you see this, because we will not be able to again go up and down. So you should understand this, that there are three blocks here. This is tie line power block, and the whole is the two rear frequency control. Now after applying the integrator, our system will be like this. This is just being the wig. Here it is a S. This integrator is applied, or you can say this integrator KIS. This integrator is applied. Rest system is same. You see, power system, that is the generator system, speed governor, turbine, 1 by R1. Up to here you have seen block 1, block 2, and finally this was the frequency F1, and area 1. This was the area 2. Again generator, speed governor, turbine, and finally this was the area 2. And F1 minus F2, it was the tie line power, which you described earlier. But in addition to that, here you see this integrator is also connected. Yeah. This figure is again repeated here in the same with the intention that here X1, X2 is written. This is called as X1. Change in frequency is called as X1. this signal was x2 already, this was the x3, and this was the u1 already. Here it is 1 by s. What we did here, additional. This is connected here. It is not open. It is connected here. And this signal, that was the frequency. X1 is nothing but it was the frequency. This frequency signal with some gain of B1 is applied here, and then the integrator is applied. And the tie line power. According to the tie line power also, this signal means either tie line power changes or frequency changes. It allows the integrator to integrate this signal and finally converting this signal into the YE. YE means opening of the fuel. So this was the secondary automatic load frequency control. Now how to perform the analysis means how to find what will be the response after applying this integrator. Then it is the same as we did earlier. The analysis, the process of analysis is same. Here we write the differential equations x1 by this. This is the same equation which we have written earlier, so I am not writing it again. It is x1 divided by this equation. Then taking numerator and denominator on this side, numerator on this side, denominator on that side, and finally writing s is equal to d by dt. Then the equation number 1 comes, which we already know that what is the equation number 1. Then this x2 by x3, x2 by x3 is equal to this, x2 by x3 is equal to this. So x3 multiplied by this is equal to x2, and when you multiply x3 with this, s means x dot will come, x3 dot. So x3 dot here, x2 dot equation here. Then here x3 divided by this, x3 divided by this signal. And what is this signal? u1 minus this x1 divided by r1. So x3 divided by u1 minus x1 by r3 is equal to this transfer function. When this take transfer numerator and denominator on that side, so this will be on this side. So x4 dot equation will come. In addition to this, this is a new. This is a new. So what we did here, you see this x8 dot, x8 here, you see x8 is equal to this x8. New has came, variable has came here. So it is a, you see from here, x1 v1 plus tie line power means x7 is equal to 1 x8 divided by this, x8 divided by x1 v1 plus x7 is equal to x8. So this s will go on this side, x dot will be equal to this. Similarly, so there are two more equations in addition to the previous. Here you see equation number 1, 2, 3, 1, 2, 4, 5 is same. 1, 2 means area 1, 4, 5 for area 2, x7 is the for tie line power. Only equation number 3 and 4 will be changed. Equation number 3 will be changed like this, and equation number 3, and here on the area 2 expression number 6 and and equation number 8 and 9 will change. This we have just described equation number x8, equation 4 x8. So here equation 4 x8 you have written, equation number x3 because this is again slightly changed here. So with this intention, we are able to write now. We are able to write these equations are common 1, 2, 4, 5, 7, which we have described in the previous case, that is in the last lecture, yesterday's lecture. In addition to that, these equations are modified, x3 dot and x6 dot. New addition x8 dot has came out here. So writing all these equations x8, x9, if you write all these equations in the matrix form, then this will be, if you write all in the so this type of model will come when you write all the 9 equations into the matrix form, because we know x dot means x1 dot, x2 dot, x3 dot, x4 dot, x8, x4, 5, 6, 7, x8, x9 dot, like this. So x1, and what is x1, x2, x3? These are the system variables, where x1 is the frequency, x2 is the power, turbine power, x3 is the opening, x4 is again the frequency of area 2. Similarly, x7 is the tie line power, and like this. So all the system variable, this is the system matrix. This equation will come. This is the control matrix. X dot is equal to ax plus bu. Such type of system will be developed. And if you want to solve this equation, if you want to solve this system, x dot is equal to ax plus bu. So any system, if you want to solve, this is like this: x dot is equal to x plus bu, and y is equal to cx, which y can be any value, any state variable, x1 or x4 or any other. If you want to solve this equation, we can take the Laplace of this. If you take the Laplace of this, it will be the Laplace of x dot will be the sx dot minus x0, initial state, and ax, Laplace of ax is this, Laplace of u is vus. So after ax here and xs is here, bringing this xs on this side, it will come here si identity matrix, si minus a xs is equal to vus. So xs is nothing but si vu inverse this. So if xs is known, xs means system variable, x1, x2, x3, all, Laplace of all. And if you want to, our intention is to find the xt, means what are the time response of the all variable, x1, x2, x3, what are the time response. So then we can apply the convolution theorem. We normally apply how to solve this type of Laplace equation, big system matrix. We apply the convolution theorem, and according to the convolution theorem, which you have studied in your previous BTech classes, this xt will be the 0 to 2, 0 to t, phi t minus tau, b u tau d tau. This will be there. Where now it is again not easy. Where this phi t, phi, what is phi? Phi t is nothing but it is e to the power at. And what is a? A is nothing but the system matrix. And this system matrix is here. This is the system matrix. Here you see, this is the system matrix. So now you see, so phi t, once you know the phi t, and what is the phi t? E to the power at. E to the power at means identity matrix. The size of the identity matrix will be 9 by 9. A already you know 9 by 9. A multiply with ये system matrix है. This is the system matrix here. Multiply here a with t, जो हमारा a matrix है, इसको t में multiply किया तो ये आ गया. Then a square, तो ये जो हमारा system matrix है, you have to make the square of this. Then t square, multiply every term as a t square, then divide by factorial 2. Then aq, tq, q power of the system matrix. Then multiply tq, then factorial 3, and so on. So e to the power at is very difficult. It is not simple. Since it is a 9 by 9 matrix, taking the square of this, taking the cube of this, taking the fourth level multiplication of this, then adding all these, then some symmetry will be developed, and finally you can get the phi t. But phi t is not the solution. Solution response is the phi t minus tau. ये जो हमारा बन गया phi t, एक मैट्रिक्स बन जाएगा, उसमें t माइनस टाउ, b u टाउ, v क्या है, ये यहाँ पे गिवन है, इस केस में ये है v की वैल्यू ये है. तो v u टाउ, देन यू इंटीग्रेट. So it is a very tough job to get the response xt with this method or manually. Manually we can't get this method if the system size is, even if it is just 3 by 3 order, it will be difficult to solve it. And we can solve by manually, we can solve when the system matrix is of size 2 by 2. But in the power system is very big system, the system size is very big, so we cannot solve this with this method manually. That's why what we apply the MATLAB program to solve this. And the MATLAB program, you already know that there is a one command to get the response. A, write the A, what is the system matrix, ये सभी all the 9 by 9. इसमें देखिए up to here we can write all the, it is the 0 0 b2 like this. So this is nothing but is a system matrix जो यहाँ पे था 0 0 0 b2. ये पूरा का पूरा हमने all, this is row number 1, row number 2, row number 3, ऐसे करके this is the system matrix we have written like this. यहाँ तक हो गया. Then B, ये हो गया. Then AX plus BU, B और FWB से F means this, first row, second row, third, and like this. Then C which we want to calculate, and finally there is only one command, step A, B, U, C, D, like this. So when we write this command, then it gives the solution for Y and X. And if you want to plot the Y, it will plot. When you write T is equal to Y में क्या आएगा? For every 0 second, every 0.0 second up to the 30 second, it will calculate T and Y, means Y1, T1, Y2, T2, Y2, T3, like this, and that will be plotted here. And that plot you can see here. It will be like this. Means there is no steady state error here. You see, earlier what was the frequency? Frequency हमारा change होकर यहाँ ऐसे stabilize हो रहा था, and there was a steady state error. As the theory says, and in this program also we can say there is no steady state change. Finally, frequency after disturbance, if the load changes from 100 to 110 megawatt, frequency changes, but finally it is stabilized here. And why it is stabilized? There were two reasons: because of the primary automatic load frequency as well as because of the secondary load frequency. Steady state error removes because of the secondary load frequency. Okay, so this is the case. Is there any question? This the same thing. The same thing we can do in the Simulink also. You also study the Simulink programs in your laboratory class. You apply drag and drop method from the that window, Simulink window, right? Drag and drop of generator, then turbine, governor, and this again, etc. And writing this, running this, and finding the output here, and then you can find the same response will come. What we did in the program, the same response will come in the Simulink also. This response will come. Is there any question up to now? यहाँ तक किसी को कुछ प्रॉब्लम है? जब तक आप खुद सॉल्व नहीं करेंगे चीज़ों को, बाई हैंड नहीं करेंगे, then it will be difficult to understand. आपको चीज़ें ऐसा लगेगा कि ठीक तो हैं, लेकिन आपको चीज़ें क्लियर नहीं होंगी. So is there any question up to now? Deepika, are you understanding the things? Hello?
Yes sir.
कौन मितेश बोल रहे हैं?
Yes sir.
Okay. चीजें क्लियर है कि नहीं है?
Yes sir, clear है sir.
Okay. Now we have seen. Now the last topic of this is AGC. Last topic of AGC. After that there is a voltage control. Then the unit will be finished. So till now only half unit is just going to be covered. So here you have seen what we have seen in this or otherwise also. Here we apply the feedback. किया हमने ये तो किया था, इंडिकेटर लगा दिया था और ये फीडबैक यहाँ से फ्रीक्वेंसी से फीडबैक लेके, and this was given here, and finally we have seen the steady state error is removed. Now question arises, why here? What is our intention? Whether we can do the better control or what is done by the integrator. Integrator ने जो response दिया है उससे क्या हम अच्छा कुछ कर सकते हैं? And what is the meaning of better? Better का मतलब क्या है? Frequency steady state error, it is removed. Again we want to improve the system. Then what is the meaning of this? What is the meaning of improvement? Improvement can be that it is a overshoot. It goes up to here and finally it stabilizes. So one thing is, this is a settling time. How much time it takes to settle? Settling means when the range is within the say 2% or 5%. ये जो हमारा overshoot है और जो ये limit है ये है इसके 2% ऊपर नीचे तक के रेंज में आ जाए, तो ये क्या कहते हैं, ये सेटल हो गया सिस्टम, हमारी फ्रीक्वेंसी आ गई. कितने टाइम में आ गई? इतने सेटलिंग टाइम में. तो हम सपोज ये यहाँ पर आ गया 2% की रेंज में, देन वी कैन से दिस टाइम इज इक्वल टू हियर दिस इज व्हाट इज द टाइम 15 सेकंड. वी कैन से इन 15-20 सेकंड में हमारा सिस्टम स्टेबलाइज हो गया. बट नाउ देयर आर वी वांट टू इंप्रूव द सिस्टम, देन व्हाट वी कैन से सिस्टम शुड बी स्टेबलाइज not only in the 15 second, but it should stabilize in early time. Early time means अगर ये हमारा 5 या 10 सेकंड में स्टेबलाइज हो जाता, then we can say the system is good enough. So this is the always the chance to improve the system. Another thing is this overshoot and peak shoot. ये हमारा जा रहा है ऊपर नीचे, तो ये minimum जाए. So with this intention, we want to improve the system. तो if we want to that ये overshoot undershoot ना हो या जल्दी settle हो जाए, तो हम क्या करेंगे? Then we define an error. What is the error? Error means क्या है? ये ऊपर जा रहा है, तो ये जो एरिया है x1 ये ऊपर गया तो x1 ये एरर हो गई, ये इधर आया ये भी एरर हो गई. ये if we consider these are the error and if you sum them then x this equal to this and then it is 0, but we want the error should not be there, so what we say we square it. ये x1 की वैल्यू है, इन्होंने इसको स्क्वायर कर लिया, इसको भी स्क्वायर करेंगे तो माइनस माइनस प्लस ये स्क्वायर हो गया, तो ये ऐसे ऐसे सिग्नल आ जाएगा दोनों एक ही साइड में ऐसे मींस. और जब ये एरिया है इसको हम मिनिमाइज कर दें तो हम कहेंगे मींस दोनों तरफ ना तो पीक और ओवरशूट और अंडरशूट कुछ नहीं हो रहा है, या कम मिनिमाइज जितना कर पाएंगे. इफ दैट एरिया ऑफ पीक एंड peak overshoot and undershoot is minimized, then we can say the system performance is good. System हमारा बेहतर हो गया in comparison to the when it is not applied. So this is our intention. With this intention, what we see, तो हमने क्या किया था, ये फीडबैक सिग्नल हमने फ्रीक्वेंसी यहाँ से लिया था. Now question is why to take the frequency, the feedback signal from here? Why can't we take the feedback signal from every stage? यहाँ से भी एक फीडबैक लें, यहाँ से भी फीडबैक लें, यहाँ से भी लें और यहाँ से भी फीडबैक लें. Nowadays अभी वायर्स की जरूरत नहीं होती है. We know we have the optometry control. सिग्नल हम रिमोट लोकेशन से भी ले सकते हैं, तो यहाँ से सारे सिग्नल लेके हमने यहाँ दिए, यहाँ के सारे सिग्नल लेके यहाँ दिए. तो then we can say whether when one signal can do a very can improve the result, why can't if the other signals are tried and to get the better result. So with this intention we apply the control theory, optimal control theory. यहाँ हम optimal control theory apply करते हैं where the system is same, x dot is equal to x plus bu. This is a plant which is the x dot is equal to ax plus bu. ये system है हमारा. by is the output cx and here the x1 x2 x3 x4 x9. जैसे 2 एरिया है तो x9 हो गया और सिंगल एरिया है तो x1 x2 x3 4 हो गया. So now जैसे हमने अभी देखा था एक ही सिग्नल आउटपुट लिया था. Now what we are trying, we are taking more signal x1 x2 xn सभी के सिग्नल लेके इसमें दिए. So then you can say this u जो हमारा u था, u is nothing but u is equal to minus kx. u की वैल्यू माइनस kx, तो हमारा सिस्टम क्या था, x डॉट इज इक्वल टू ax प्लस bu. तो u की जगह अब इस u की जगह माइनस kx लिखा है यहाँ पे. When you write u is equal to minus kx, this equation will come ax minus b u की जगह ये लिख दिया. तो now taking x t common, then x dot is equal to a minus b k x t dot. You can write it as af x t means x dot is equal to ax where a has been changed to the af. जो हमारा सिस्टम मैट्रिक्स था वो ये चेंज हो गया बिकॉज दीज वैल्यूज हैव एंटर्ड इनटू द सिस्टम k1 k2 k3 इसकी वजह से. नाउ व्हाट इज द k एंड हाउ टू बी कैलकुलेट द k है क्या. अगर हमारा सिंगल एरिया सिस्टम था तो u इक्वल टू माइनस u कैसा होता, एक ही इनपुट होता. अगर सिंगल एरिया सिस्टम है तो इनपुट ये u1 ही होता. u1 होता तो यू कैन राइट u1 इज k1 x1 k2 x2 k3 x4 and like this kn x k4 x4 like this. But if it is two area system, u1 इधर भी है u1 इधर भी है. There are two u1, so you can u1 u2. u1 is the k1 x1 k2 x2 k9 x9 and u2 will be the k1 x u1 u2 can also be the same. So can be in place of k1 you can say k1 dash k2 dash k3 dash like this. So now our system can be like this. If it is 2 area, 2 row will be there. If it is 3 area, the 3 rows will be there. क्योंकि जितने u1 होंगे जितने एरिया होंगे जितने इनपुट होंगे उतना ही हमारा u1 होंगे. Now what we are trying to do, our intention is to find the value of k. इस k की वैल्यू क्या हो. अब मॉडर्न कंट्रोल थ्योरी जो हमने बीटेक में पढ़ा है उसको अप्लाई करके हम ये निकालेंगे व्हाट शुड बी वैल्यू ऑफ दिस k so that the performance is best. Performance बेस्ट पॉसिबल। जो हमारा ये परफॉर्मेंस था, इसकी बेस्ट परफॉर्मेंस क्या हो सकती है, मीन्स ये हमारा सिग्नल ऐसा हो जाए, मीन्स ये एरर, ये वाला जो एरर है वो मिनिमाइज हो जाए, और ये टाइम सेटलिंग टाइम मिनिमाइज हो जाए। वो कब होगा, जो अभी आपको बताया है कि जब आपने x1 स्क्वायर, x2 स्क्वायर, x3 स्क्वायर को इंटीग्रेट करके उसकी वैल्यू मिनिमाइज करेंगे। तो विद दिस इंटेंशन वी वांट टू फाइंड आउट व्हाट शुड बी द वैल्यू ऑफ k1, k2, k3। ये इनकी वैल्यू क्या हो, और व्हाट शुड बी द वैल्यू ऑफ, यू कैन से these so that the system performance is best possible. So with this intention now, एक तो अभी प्रॉब्लम डिफाइन नहीं हुआ है, प्रॉब्लम भी डिफाइन करना है कि हमने अभी क्या था, परफॉर्मेंस बेस्ट हो, परफॉर्मेंस बेस्ट हो, परफॉर्मेंस को ये डिफाइन किया है x1 स्क्वायर, जो अभी आपको बता रहा था, व्हाट इज द परफॉर्मेंस x1 स्क्वायर, x2 स्क्वायर, x3 स्क्वायर, इन सबका इंटीग्रेट करें। मींस एरर, ये जो एरर आ रही है ना, ये x का x में एरर, x2 में एरर, x3 में एरर, उन सब एरर को ऐड कर दिया, स्क्वायर ऑफ दोट एरर इज ऐड, दिस इज कॉल्ड द परफॉर्मेंस। दिस परफॉर्मेंस शुड बी ऑप्टिमाइज, ये ऑप्टिमाइज होना चाहिए। अच्छा, सपोज इसको हमने ऑप्टिमाइज करके इसे सॉल्व कर लिया है, सॉल्व करने के बाद पता लगा कि इट इज सेइंग फॉर बेस्ट परफॉर्मेंस Q1, आपको सपोज करिए फॉर एग्जांपल, मैं केवल एग्जांपल दे रहा हूं कि जो हमारा ये सिस्टम था, इसमें आया परफॉर्मेंस सॉल्व करके आया, दिस U1 शुड चेंज, ये U1 था ना, ये यहाँ पे U1 शुड चेंज लाइक दिस, कि हमारा U1 इतने से इतने परसेंट इतने टाइम में हो जाना चाहिए। बट देयर आर लिमिटेशन ऑफ U1 टू चेंज। U1 मींस इनपुट फ्यूल ओपनिंग कितनी फास्ट चेंज हो सकता है, या उसकी लिमिटेशन है, मिनिमम मैक्सिमम लिमिट भी है, तो आप इससे ज्यादा यू चेंज नहीं हो सकता। तो इट मींस द परफॉर्मेंस में हमें लिमिटेशन भी ऐड करना पड़ेगा, एंड दैट इज तो देखिए, इसको हम अगर शॉर्ट में लिखें, ये इक्वेशन ना, x1 स्क्वायर, x2 स्क्वायर, इसको ऐसे लिख सकते हैं, x ट्रांसपोज x क्या था, x1, x2, x3, x4 ऐसे था ना, कॉलम मैट्रिक्स, ये रो मैट्रिक्स बन जाएगा, ट्रांसपोज इट विल बी रो मैट्रिक्स लाइक दिस, x1, x2, x3, x4, और ये कॉलम मैट्रिक्स, व्हेन यू अप्लाई रो इनटू कॉलम इट विल बी x1 स्क्वायर, x2 स्क्वायर लाइक दिस, ये इक्वेशन बन जाएगा, ये J परफॉर्मेंस पे। और इसमें हमने फिर अभी आपको बताया इनपुट में कंस्टेंट्स भी ऐड करें, ये इसको करेंगे तो इसके अलावा इन एडिशन टू दैट ये हमारा जरूरी नहीं है कि x1 स्क्वायर, x2 स्क्वायर को हम विद आवर एक्सपीरियंस वी कैन से दैट द इफेक्ट ऑफ x1 इज मोर, तो हम ये वेट अप्लाई कर सकते हैं Q1 इज हायर, देन वी अप्लाई, सपोज द इफेक्ट ऑफ x2 is less, we can apply the weight here, 0.1 या 10 लग दिया या 0.3 लिख दिया, so we can apply the weight to find to this performance। तो ये क्या हो सकता है, Q, you can say it is not x dot x transpose x, but it can be x transpose qx, where Q is the constants of this another matrix here like this, Q can be like this, so performance index is now defined as a x transpose qx, and constants is u transpose, इनपुट में u1 u2 में कंस्टेंट हो सकते हैं, u ट्रांसपोज ru, where r is the input variables and the q is q1, q2, q3। we have to select q1, q2, q3, qn and r1, r2 such that this performance is maximum, ये परफॉर्मेंस मैक्सिमम हो किस सिस्टम के लिए, x डॉट इज इक्वल टू ax प्लस bu। जो हमारा ये सिस्टम है, इस सिस्टम के लिए इस सिस्टम के लिए परफॉर्मेंस मैक्सिमम हो। इज देयर एनी क्वेश्चन अप टू नाउ?
नो सर।
हाँ, विद दिस इंटेंशन वी विल मूव अहेड, मतलब अब आपको प्रॉब्लम समझ, अब तक हमने कोई सॉल्व नहीं किया है, हमने केवल प्रॉब्लम को एक्सप्लेन किया है, दिस इज द ओनली प्रॉब्लम। नाउ हाउ टू सॉल्व इट, दिस इज अनदर क्वेश्चन, कि हमें परफॉर्मेंस इंडेक्स पता लग गया, हमने डिफाइन कर दिया व्हाट इज द परफॉर्मेंस इंडेक्स, एंड दैट शुड बी ऑप्टिमाइज्ड। किसी भी परफॉर्मेंस इंडेक्स को, किसी भी सिग्नल को ऑप्टिमाइज करना है विद दैट इंटेंशन कि हाँ, तो ऑप्टिमाइज करने का क्या प्रोसीजर होता है, नॉर्मली जो हम इकोनॉमिक डिस्पैच वगैरह बीटेक में पढ़ा है, कोई भी सिस्टम है, कोई इक्वेशन है, सपोज एक इक्वेशन है x इक्वल टू 5x स्क्वायर प्लस 10, इसको मिनिमाइज करना है, मींस इसकी वैल्यू मिनिमम कब होगी, तो क्या करेंगे, इसको क्या करते हैं,
डिफरेंशिएशन,
उसको डिफरेंशिएशन करके और
0 के इक्वल रख देते हैं।
0 कर देते हैं। जो वैल्यू आती है x की वैल्यू पता लग जाएगी, उसमें हम रख के देखेंगे तो मैक्सिमम आ जाएगा, मैक्सिमम और मिनिमम आ जाएगा। मैक्सिमम आया, मिनिमम आया, डबल डिफरेंशिएशन से पता लग जाता है। Similarly, same thing we will do here, but little bit different because here x is not a single equation, it is a matrix. एक तो ये मैट्रिक्स है और number of equations are there. So we will apply not the differentiation but another thing is the partial differentiation. इस partial differentiation किसका, जो हमने परफॉर्मेंस इंडेक्स डिफाइन किया है यहाँ, ये इक्वेशन है, इसमें ये परफॉर्मेंस इंडेक्स को इसको बेस्ट बनाना है। तो इसको करने के लिए हम क्या करेंगे, इसका डिफरेंशिएशन लैग्रांज फंक्शन डिफाइन करेंगे। फर्स्ट ऑफ ऑल वी विल डिफाइन द लैग्रांज फंक्शन, देन वी विल अप्लाई द डिफरेंशिएशन, पार्शियल डिफरेंशिएशन, देन वी विल सी व्हाट इज द रिजल्ट एंड दैट रिजल्ट विल बी द बेस्ट ऑप्टिमम रिजल्ट। मींस हमें क्या आ जाएगा उससे, वो कंडीशंस आ जाएंगी सारी जो हमें बेस्ट परफॉर्मेंस रिजल्ट देगा। मींस क्या कंडीशन आ जाएंगी, K1 K2 K3 इनकी वैल्यूज आ जाएंगी, इन वैल्यू पे हमारा सिस्टम बेस्ट होगा। और K1 K2 K3 इनकी वैल्यू आने से का मतलब क्या है, हमारा फीडबैक पता लग जाएगा, हर एक सिग्नल से हम क्या क्या फीडबैक ले जाएं। ओके, सो आई थिंक द थिंग्स माइट बी क्लियर, चीजें क्लियर हो रही हैं आपको। For better understanding, you please go through the books. बुक से भी जाइए। जब क्लासरूम टीचिंग होती है then it is slightly different. आप क्वेश्चन पूछ सकते हैं, मैं चौक से उसी समय बता सकता हूँ, बट हियर you have to go through the books. साथ के साथ जाइए, साथ के साथ आप सॉल्व करिए, लिखिए, एनालिसिस करिए, फिर क्वेश्चन करिए। it may be better if you do one day earlier also. उससे पहले भी कर लें तो यहाँ और अच्छा रहेगा। So please go through the theory and try to solve the. In the next class we will cover this AGC control. Whatever the numerical is on this topic, the assignment is one assignment on LFC is also loaded. Although few assignment has been loaded, but since the theory has been covered for this AGC, so you need to solve only. You try to solve the questions given on AGC. जो AGC के क्वेश्चन दिए हैं आपको क्लासरूम में ही असाइनमेंट अपलोड की हुई है, वो क्वेश्चन भी आप साथ के साथ सॉल्व करना शुरू कर दें। ओके, सो आई थिंक इफ देयर इज नो क्वेश्चन वी कैन।
सर अटेंडेंस लगाना रहेगा।
सर अटेंडेंस लगा देना सर।